Hello friends, today I am presenting a paper on a multi-agent potential field-based bot for a full RTS game scenario. The authors for this paper are Juan Hackelbeck and Stephen Johansson. Real-time strategy bot is a challenge. Why? Because it has to perform several tasks in hand, from collecting resources, constructing buildings, to wisely spending its resources and executing attack strategies. Conventional pathfinding methods might not work in such highly dynamic game. Here in this paper we use the idea of potential field for RTS game pathfinding. So what is a potential field? So it is a technique originating from the area of robotics, where it is used in controlling navigations of robots and in dynamic environment. Like for using it, one of the use is robot soccer game, or to develop a mobile sensor network deployment system. Discuss about multi-agent potential fields. The methodology for designing a multi-agent potential field-based bot in real-time strategy game environment. The method consists of 6 steps: identifying the objects, identifying the fields, assigning the charges, deciding the granularities, agentifying the core objects, and constructing MAS environment. The same methodology is used for RTS game scenarios as well. You may ask, where was this actually tested and being played? So Open Real Time Strategy (ORTS) is a platform, a real-time strategy game engine developed as a tool for researchers within AI in general and game AI in particular. ORTS uses a client-server architecture with a game server and players connected as clients. Users can define different types of games in scripts where unit structures and their interactions are described. All types of games, from resources gathering to full-time strategy games, are supported. Talk about the project scope. The paper proposes to handle a complex RTS game in ORTS Bruno 2007. It improves the methodology of paper MAPF based bots, and in this game there are two players with 5 workers at control each center, and each of them control a center. The workers gather resources and construct new control centers, barracks, or factories. A control center serves as a drop point to resources gathered by workers, and it can produce new workers as well. Barracks are used to construct mines, lightweight combat units. If a player has at least one barrack, it can construct a factory. Factories are used to construct tanks, heavy combat units with long fire ranges. A player wins by destroying the buildings of the opponents. The game also contains a number of neutral units called shield, and these are small indestructible units moving around randomly to make the pathfinding more complex. Well, let's start the method by using identifying objects. So the objects in our applications are workers, miners, tanks, control centers, barracks, factories, cliffs, and neutral objects like ships and minerals. Okay, now these are the potential fields identified for the game navigation, like field of navigation, strategic fields, field of exploration, tactic fields, field of spatial planning. So field of navigation contains all the objects that might impact the navigation, and it will produce the repelling fields to avoid obstacles for agents. So the obstacles such as own units, buildings, minerals, sheaves, and terrains. Strategic field. This field contains the goals of our own agent and is an attractive field, different for each agent type. Fields of exploration. This field is used by workers assigned to explore the game world and attract them to unexplored areas. Tactic fields. The purpose of tactic field is to coordinate movements between our agents. Field of spatial planning. This field helps us finding suitable places on the map to construct new buildings such as control areas, barracks and factories. Now let's cover step 3 and 4 altogether of assigning charges and granularities. Each game object has an effect on navigation or tactics of our agents has to set to changes which generate a potential field around the center of the objects. All fields generated by objects are weighted by the sum to form a total field which is used by agents when selecting actions. Initial set of actions are handcrafted. So for step 3 and 4, let's start with opponent units. So in opponent units, there are two scenarios. First is attack, where the opponent units generate attracting symmetric surrounding fields, where the highest potentials are at the radius equal to maximum shooting distance, as also known as MSD for the enemy units. Second is cooldown moment. So after attacking units have fired its weapons, the unit enters a cooldown period where it cannot attack. In these cases, opponent units generate repelling field with radius slightly larger than MSD. However, the fields generated by game's objects are different for different types of own units. Let's say for example, tanks typically have a longer fire range than the examples of a marine. Hence, on, hence this is the following. Hence, this is the following that we use for potential and distance using the enemy object type and own object type as the attributes. Well, for own buildings and minerals, both have repelling and attractive fields. Repelling is to avoid collision, and attractive is in the cases where workers go for minerals and returns with minerals to the center. Now, in case of now, now in case of field exploration, the field is usually attractive charges with positions in the game that have not been explored. But this might generate attractive potentials all to the unexplored areas. In this case, explored units tend to get stuck somewhere in the middle of the map due to attractive potentials generated for unexplored areas in several directions, which is which which is as explained here in this. The potential formula is shown here. Hence, to solve this, we calculate an importance value where each terrain tile explore value E of xy is initially set to 0 in each frame. E of xy is increased by 1 by all passable tiles. But if a tile is visible by one or more of our own units, its current E of xy is set to 0, which you can see here. The importance value is calculated. Now let's move to next step, that is agentifying. So each own unit is represented by an agent in the system. The purpose of these agents is to coordinate own units to work towards common goal rather than letting them act independently. The first of these agents is Commander-in-Chief, responsible for making a battle plan. The battle plan contains the order of creating units and buildings. The battle plan is as shown in this figure. Okay. So, for example, while constructing factories, if these for example, while constructing factories, if barracks are destroyed for workers or workers are killed, then we still need to first reset the previous tasks, that is like build the barracks and get the workers running up and running. and then resume the current work, that is constructing the factory. It also contains special actions, for example, sending units to explore the game world. Well, now our second agent is Commander in Field. This agent is responsible for executing the battle plan generated by Commander-in-Chief. This agent is specially divided into three parts, and it gets additional help for executing battle plan. First is Global Map Agent, Attack Coordinator, and Spatial Planning. So Global Map Agent, in this, our bot has a dedicated global map agent in which all detected objects are reported. Agent always remembers the location of previously spotted enemy bases until a base is destroyed, as well as distributes the positions to detect enemy units to all our own units. Next is Attack Coordinator. So the agent optimizes attacks at enemy units. Let's say, for example, let's consider this example where if you see in the figure, A, B and C are A, B and C are our own units which have 3-level damage. Now, if an attack the weakest strategy is used, Unit A will attack Y and B and C will attack X, with the result that both X and Y will survive. By letting the coordinator agent optimize the attacks, all units are coordinated to attack X, which is then destroyed, and Y will only survive. Next comes the spatial planners. This is to seek out a suitable location to construct our own buildings. Own buildings generate a field with an inner repelling area to avoid construct buildings too close to each other, and an outer attractive area to build to be grouped together. Whereas enemy buildings generate a repelling field, obviously to avoid collisions at that point. It also avoids minerals, impassable terrains, cliffs, game world edges as well. Let's talk about experiments and results. The experiments were taken during ORS tournament of 2008. The opposite team used hierarchy of commanders for major tasks and A-star algorithm for pathfinding. And as you can see, the opponents as UOF won 17.5% and and the Papers University Belking won 82.5% times. My take on this whole paper is potential field summation gets the decision making process very easy and fluent. Well, few parts like battle plan hierarchy are very rigid and can make it more dynamic to adapt to changes. As if the battles is as in if the barracks are, if one of the barracks is destroyed, but there's enemy attacking at the other end, the workers should be trained and to take away the tanks and marines to attack them first, then to rather than pausing the attack and going back to the construction work of barrack. Thank you. Thank you so much for going through this.